Well, thank you, Bill, remotely. Our last presentation will be given by Joe Stilwell. Joe is a senior project manager with the Maine Department of Transportation's multimodal program, where he oversees rail and marine infrastructure projects. He recently served as the National FRP Composites subject matter expert for the U.S. Army Corps of Engineers at the Inland Navigation Design Center of Expertise. In both roles, Joe has been a strong advocate for the adoption and implementation of composite materials in civil infrastructure and continues to support the U.S. Army Corps of Engineers as an external reviewer for its FRP program. Joe holds a degree in mechanical engineering from the University of Maine and is a licensed professional engineer in civil engineering. His background spans bridge construction, structural design, and project management. He's a voting member of AASHTO's Product Evaluation and Audit Solutions Composite Concrete Reinforcement Audit Program, where he developed the work plan for auditing and sampling GFRP reinforcement. Joe also serves on the IACME Infrastructure and Construction Working Group and is a friend of the AASHTO Specialized Structures Committee and is currently a member of the Task Force from AASHTO on Composite Material Specifications. Joe?
All right, quick disclaimer. I am not representing the Army Corps in any way. I'm just presenting this on behalf of my highly overworked colleague who I abandoned when I came back to MaineDOT. So many people don't know that the Army Corps of Engineers is a major asset owner in their Civil Works program, like many DOTs are. So they have major structures that are billions of dollars. Couldn't believe some of the stuff when I saw when I was there. But this is just a quick snapshot of a lot of the steel type structures they have controlling your navigation waterways. So the Ohio, the Mississippi, all of those real infrastructure important locations. So locks and dams that span the Mississippi River. Those big roller gates are 120 feet long. Some of them are 40 feet tall. So we're talking millions of pounds of steel literally sitting and operating in the salt water and fresh water all over the country. So you got locks and dams. The bottom one's a sector gate. That's in Canaveral. Outside, you can watch rocket launches from there. Flood risk management. So a lot of dams, that's hydropower, but it also keeps the water back so people's houses don't get washed away. And then these need maintenance. So they need large dewatering structures, now currently made out of steel, to put in there while they can do their 5, 10, 50-year maintenance. Oh, that's why I get pushing the wrong button. So you have all of these billion-dollar structures scattered all over the country. There are thousands of locations with tens of thousands of different components. So it's kind of a snapshot. Yeah, I was working for Army Corps Inland Navigation, no structures up here. It was fun. Had to fly everywhere. So like any steel structure sitting in water, protected by coatings, aging infrastructure and corrosion, same old song, everyone's heard it every day. So forward thinking, the Army Corps looked at a problem statement, put a bunch of officers in a room, problem statement, find solution. So steel structures require reoccurring and costly maintenance. There are over 13,000 structures that were built between the 20s and the 70s, all coming to the end of their 50-year design life at that point. So looking at a 60-year holistic chart, you need to replace 260 structures per year, minimum, in order to maintain the average, which is the tune of $1 to $2 billion, which was never going to get funded by Congress. So the solution was another tool in the toolbox. So through research and actual projects, the FRP is offering a significantly longer service life with much less maintenance required. A lot of the cost charrettes have been showing that because of how complex USACE structures are for steel and fabrication, it's actually coming out to be similar first costs, which surprised a lot of people. Bridge girders are simple. Locks and dam structures with their lattices and all that complicated angles, very long years to refabricate a steel structure. And faster design. So instead of doing deep, detailed design, do a design build type project or MaineDOT a detailed build. Put outlines on plans, do a performance-based spec, put it out to the fabricators and their design teams to come up with the solution. So very performance-based spec, not very prescriptive. And looking at the long-term life cycle cost savings, which were great fun. Significant savings between 3 to 1, 5 to 1 on smaller structures and the big complex structures, especially those in salt water. 10 to 1 is a real number over the 100-year lifespan. So one of those things is, like anything, they've been looking at this for a while. As people have known that the US military, both Army and Navy, and Air Force have been playing with composites for a long time, not a new thing. So they started in the 90s, military research in the early 2000s. So this is just a continuation of already adopted and proven technologies. So with that, one of my good colleagues, I call him the godfather of the program, got a bunch of projects funded, because that's kind of the valley of death. You got research being complete, projects implemented. How do you get there? You need to have funding. So he managed to get a bunch of funding packages put in. He was out of the South Atlantic Division, so a lot of these are in the South. But to kind of get demonstration projects, get the Corps familiar with it, work out the kinks in the system, get our specifications, get the contractors used to doing business with the federal government, which is always an adventure. And earlier this summer, or last summer, ERDIC out of the Serial Lab in Champlain kind of put out a special report that said FRP is a mature technology. It does not require any additional research, full stop, for adoption for applicable structures. And these are charts out of the report. Pretty much any of the large hydraulic steel structures that the Army Corps use is an applicable thing. Like anyone who's done the FRP, it's not great for point loads. So you still need to have steel components in there for lifting arms and things like that. And there is a huge list of already commercially available products that can be utilized immediately. So like anything, Maine, Army Corps, not the first to do anything. The Dutch were well ahead of everyone. So the Rijkswaterstaat has their own miter gates. Those are 40 by 60 foot leaves. There is a 20 by 40 foot vertical lift gate on their dike and holding the North Sea back from flooding them. And that is the in construction pedestrian bridge that's being done on national lands, done out of the South Atlantic Division. It's the first one where it's protruded structures or actually have kinks in them. So it's kind of all put together like a normal steel structure. It's not full straight. So been really, really successful in other locations. So a lot of people asking, well, how do you get the states to cooperate and get things doing it? Very similar with all the Army Corps districts, but in order to combat that, myself and a couple of others working together with headquarters, use the purse strings. So a engineering guidance went out about July of last year, which requires all of the districts to do a 100-year life cycle analysis for any repair or replacement of existing structures. If a budget package was put in that did not have this done, it was kicked back. And yes, some districts tried to do it. I got a lot of last-minute phone calls of saying, help, we need to do this because our budget package got rejected. And so and their goal is to transition where appropriate and cost-effective. So we're not going to be putting an FRP on a 100-foot high head where if it goes, it's going to kill millions of people. It's targeted approach using engineering judgment. And like anything, updating the guidance with the state of the science. As we learn more, we'll update things. So just kind of a overview of opportunities on a standard structure that could replace this, not just the huge big ticket items. So normal lock, 1,200 foot long, 110 foot wide, 40 to 60 foot deep, massive structures. So everything in yellow, we kind of identified as this is steel. Why can't it can be replaced as FRP. You notice everything on there, I'm sure you can see the slides bigger, that's not concrete, says it can be pretty much FRP, and including the reinforcement of the concrete. I'm a firm believer of why we putting black steel in the ocean. Been doing composite stuff for a while. It always bothered me. So just kind of jumping through some of these smaller stuff. Handrails and gratings. There's 20, 30 commercially available structures that you can do that. So why aren't they just with all their steel stuff and catwalks on these structures? Why does it do FRP in their thing instead of going galvanized steel? Trash racks, bulkheads, and floating mooring bits. So trash racks are the gates that prevent debris from going into the filling valves because it's opening and closing. It's a huge system of gravity to raise and lower locks. Valve bulkhead, so flat plates with girders in them, pretty straightforward. And then floating mooring bits. So these floating mooring bits are what barges tie off onto in the lock, and they float up and down to keep barges in place. They're a welded pipe. What happens when a welded pipe gets a hole in it? It sinks. So instead of having floating mooring bits that aren't being useful, why not use an FRP tube filled with foam? Will never sink. And of course, there's sheet pile and pipe piles. It's everywhere. MaineDOT has been doing it. That's a 4.5-foot pipe pile going to a marine project for a turning dolphin. That's out of Composite Advantage in Dayton, Ohio. And of course, PVC sheet pile walls, Army Corps project in the late 90s in Louisiana. So been around, been there forever, commercially available off the shelf. And then mooring dolphins and cells. I don't know what it is, but the Corps has a deep love of using timber. Timber breaks. Steel, when they use steel, provides a distinct shock. These mooring dolphins actually can take, deflect, and return back, so any impacts doesn't damage the boats, sink barges. That's a huge problem with steel armoring of piercing a barge and them sinking the navigable waterway. And of course, concrete reinforcement. Yeah, that's a MaineDOT project. That's Ryan's Bridge. Threw that one in the presentation. But why would you ever use steel in a structure? And with the ACI 440, there's already a design code. This is actually the only solution to a current project where they have to prevent invasive Asian carp coming up the Mississippi into the Great Lakes. Illinois and the Army Corps is working on it, and they have to use electronic deterrents, I guess. So they need to have a rebar that is electronically transparent. So GFRP is the only solution for that. So kind of interesting things. And of course, you got the pedestrian bridges. This is Buford Bridge in national lands. It's kind of a cross section of it. It's about 300 feet long. And there's another one that's already in place. So the meat and potatoes, these are the currently funded in progress FRP projects. This is current as of last week. Everything in blue is fiscal year 25, which means this will be out, advertised, in theory awarded by 30 September. The Canaveral Lock sector gate you see there is currently out for advertise, and I believe it closes in 2 weeks. So that's a 55-foot radius, 25 feet tall. We need 2 of them. So big, huge structures. Lock 16 Tanner valve has been awarded, waiting on construction. Don't know if it's going to be done at Kenway in Augusta or if it's going to be done at Creative Advantages facility in Ohio. Completed those wicket gates, all fabricated here in Maine and shipped to Ohio. They've done it at Kenway. That's how I got involved with the Corps. Miter blocks done by Orenco out in Seattle area. So this is a very high lift miter gate that they used out there. Miter gate's like an arching bridge, highly complicated. And like I said, there's a huge $20 million worth of projects awarded to date, and probably another $55 million, $60 million in the pipelines for 26, 27. So, and it's all over the country. So they're actually following through and doing what they do. Had my hand in most of these things as they were going on, and a lot of good stuff out there. Boggs floating guide wall, that was a concrete box that they used to tie off ships to. Concrete got a crack in it, it sank to the bottom of the river. So looking at utilizing other applications for FRP that USACE is doing. Modifying actually one of those Navy camels that's built in like 5 container ships of FRP. So why can't we use that kind of concept for a floating barge? They're looking at it for replacing their floating plants. There are steel structures that are being worked on sitting in the water all the time. Army Corps has a huge naval fleet of their ships that they own. So this was another solution that they were looking at through their Marine Design Center. And some other cool things that have happened last year while I was there that I was involved with is using externally bonded carbon fiber to strengthen heavily corroded or damaged steel structures. So this Tanner Gate is in a highly corrosive river, so it's pretty well eaten up. So ERDIC, in combination with the district and a couple of others, and myself came up with a solution to use externally bonded to add more tension to the tension flange to keep it in service until it could be replaced. Funding cycles, 2 to 3 years out, and another 2 to 3 years to get something. So this one, about 5-year lead time from when they knew that it needed to be replaced to when they had funding and it being fabricated. And this is one of those emergency save the day. So this is in Lockport, in the Chicago district. During a routine dewatering, they noticed the casting of the pintle, which is where a 150,000 pound steel gate sits on and rotates. So that is a operationally critical location. Lead time to getting a machined casting, 6 months, year, 2 years at best. So utilizing what we learned in some finite element modeling analysis, we applied an externally bonded FRP system using 2 layers of carbon fiber as kind of a maintenance fix to put that back into service. It's being monitored, it's still in great shape, and I believe that casting it'll be closed down and dewatered shortly after the new year. So, but operationally important. There's hundreds of millions of dollars worth of goods going through this waterway. It'd be like shutting down 95 and not allowing anyone on it. So breeze through this. I know I got put up against the wall in trying to stay on schedule. So that is the contact information for my counterpart that I worked with when I was with the Corps. Kind of talk to him every week or two anyway, keep in touch. He's still picking my brain on some of the projects that are going out. With that, kind of end there. I know I brushed through it, threw a lot at you, but it's one of those Corps adopting the use of composites countrywide, full stop. Why can't everyone else? If the Army Corps can do it, and everyone knows that they are slow and difficult, and anyone's tried to do permitting. Marine applications, why can't states do it? If we got major structures, why can't another state do it? So it's kind of the sharing and some of the stuff that I've been doing. Part of my job is just getting the word out there and kind of showing in-depth applications and how it can be adopted. A lot of the stuff that we're using for the Corps is the stuff that we learned and everything over the years when I was working with AIT and those bridge girders and everything. A lot of those specs, a lot of the material properties, right into what we did with the Army Corps. So keeping going on. So there's no changes, no difference from industry. So it's one of those communication and building upon the stuff from the past. Thank you.